Okay, looks like it's a good time to get started here. So, we're going to be talking about polynomial functions and their graph. And to start off, we're going to talk a little bit about degree and end behavior. But when we talk about degree, let's make sure we're clear on what a polynomial function is. And a polynomial function is just any function where I have x's with powers on them. So I could have x to the fifth minus 4x to the cubed plus 6x squared minus 7x plus 7. Who knows? Whenever I've got a polynomial function, we're going to be really concerned with whatever this highest power term is, because that is going to determine our end behavior. Now here, I've got a polynomial, and I would say this is a degree, I can spell, degree 5. Now, I could have multiple terms out here, and notice I even skipped a couple, I skipped at least one. I skipped my 4th degree term. I don't have to represent all of my lower powers down here in order for this to still stay a 5th degree term. The other thing that we're going to care about is what is the coefficient on this term. In this case, I would say I've got a leading coefficient of 1, because I have this sort of implied 1. Now, we are going to take a look at a couple of these, and I think it's going to become fairly clear what the degree and end behavior, or how the degree affects our overall behavior. And there's a couple things I can say about this right away, is that if I've got an even degree, then I've got both of the ends are either going to be up if my leading coefficient is positive, or greater than 0, or both ends down if, say, my leading coefficient is negative. Now, if I've got an odd degree, then I'm going to end up with one end up and one end down. So let's start showing you guys what some of these things are going to look like. And we got a lot of information out here, so I'm going to just start with some of our simplest ones. And here, as long as I've got sort of a general form for a parabola here, I've got ax squared plus bx plus c, and we know that this is going to have this general shape. I've got both ends up, so this, in this case, a is positive. Now, here I've got a cubic. And with a cubic function, I'm going to start with one end down. I'm going to end with another end up. So this is a 3rd degree. This one was 2nd degree. Well, let's see what the rest of the trend would look like. This is where I'm going to say, okay, well, what happens if I have a 4th degree polynomial? Well, again, I'll have both ends up. But with this, I could have more turning points. So here, this is a 4th degree. I've got a fourth degree term, or fourth degree graph. Could look like this. A fifth degree will look a little bit like my cubic, only I can have another extra bump in here. So this is a fifth degree. So notice, every time I've got an even degree, I've got both ends up, or technically I could have both ends down. With an odd degree, I'm always going to have one end down and one end up. And I could just follow this trend along. Here if I've got something that's, say, a sixth degree, then this could have even more turning points. Seventh degree, yeah, I can have a lot of different turning points once I start doing these. And something that I want you to notice here, not just that I've got sort of my end behavior as x gets very small or x gets very large, but how many turning points? How many times does this turn? Well, with a second degree term, I've got literally one turning point, one place where it changes from being downward to going upward. So I've got, at most, I'm going to have one turning point. With a third degree polynomial, I can have 2. 1, 2. So I've got 2 turning points. With fourth degree, well, let's see, I've got 1, 2, 3. At most, I'd have 3 turning points. Fifth degree, I have 1, 2, 3, 4. And you notice I'm saying at most. I could have a fourth or fifth degree, I could have a fifth degree polynomial with no turning points at all. With a fourth degree polynomial, I have to have at least one. Same thing because these are going to have to end in the same direction, so it has to turn around at some point. But with a fifth degree polynomial, I could have something that just sort of, it might slow down, but it won't turn. But I could have, at most, I could have up to 4 different turning points. So when we're looking at the behavior of our polynomials, some of the things that are really important to notice are, what is the degree of the polynomial? And that's going to tell us a lot about what the overall shape is, what the overall shape could be, and kind of what's happening at the ends of our graph. Do I have both ends going up? Do I have one end going up and one end going down? And that leading coefficient is going to tell us which direction things start in. Alrighty, that's all I've got for now. I will catch you in the next video.